you guys working. Yeah. So we'll have the inner. This is the outer loop and then the inner loop, more or less the nested loop. So this actually takes care of the number of epochs, right? And then the number of epochs, if you don't call it epochs, you can call it iteration, but in AI, maybe implementation, we'll call it the number of epochs. So now, now you do some possible permutation process, right? You shuffle, this actually helps in shuffling process. Now, having done that, you can proceed to to do some possible iteration within the data set, so to say. So that is just what is just taking place here. So in our say for I in range up, this is just a way out of a presentation of the for loops in Python, so to say. So you are taking the range of maybe within this value 0 to the length of this. So that is just what is taking place here. If you're confused a little bit about this, you can even just go to the web. That's just a way of going about programming. You can say, okay, range in Python, range in Python. So you just check the documentation. Have you seen it? So it's even this guy is Google has just given us the answer immediately. This is just the starting point, value, the stop, the step. Have you seen it here now? So when we go here, how many do we have here? We have here, this is the starting, the what? The stop, where you're gonna stop, and this is the step size. So now you see that this is just our start. This is just our stop, where we're going to stop in our iteration process. And then this is just the stepping size that maybe from 0, this bar size, you add another bar size until you finally get the length of your what you're training. So do we have any question here? Any question here? Yeah, cool. Are we there? Man.
Yes.
So, do we have any question? I want us to understand the concept. Where you don't understand it, just let me know. Any question here?
I want you to say something on this gradient tape.
Gradient?
Yes.
Okay, okay, okay.
With
Um,
TF dot gradient tape.
okay.
Tape.
Yeah, the gradient. The gradient, right, is what actually does what we call back propagation,
No,
right?
honey. Again.
That's what really. Are we there? Get up from here. So the gradient, right, is what just does this in the balancing of the weights. Because when you go the very first one, maybe the fourth pass, you register some losses in the system, right? So it's what really causes this loss is as a result of the weight and then maybe your input plus the bias in the system. So you need to, our concern here is how do we really balance this weight so that when we go to the next iteration or the next import, our loss will be reduced with the help of our this back propagation process and then our optimization. So that is just the essence of the gradient. Are we there? Is that understood?
Yes.
Yeah. Or even I will as well share a material or you can check CS 231 by Stanford. So they have a detailed knowledge about some of these, technical terms and how some of their functions anyway. So you can maybe have a look at that. So, but then based on the bone of contention on this code, I don't know whether if we have any question, do I really proceed or do I proceed? Okay, let me just explain.
Please, what
Mhm.
guides the number of epochs?
No, you
Yes.
the thing is that
And do we just
maybe
use the
you arbitrarily, if you are
mm,
not using an external optimization function, right? You can actually um just give an arbitrary value, right? But while you are giving arbitrary value, you check the output of your model, the performance. Maybe you're using something like accuracy, right? Or maybe F1 score, something like that, to check if your model is actually performing. If it's not performing or going suboptimal, you now check, you can vary the weight, you can vary the maybe the range, you can vary the range, you can even vary the batch size. These are some things you just have to put into consideration. Are we there? So that's just what you, but then like this work here, this just a sec. Let me just overleave. So this is just my work, one of my works. Let me just uh, um, okay, I want to show you guys something. So, okay, like this work here, we actually use what you call, let me even get the name of that model again. It's a bio-inspired algorithm that we actually use. So, mhm. But maybe some other times I can put you people through on how you can make use of lattice in doing your work anyway. So let me check. Oh, there's no fire here, so just a moment. I've forgotten the name of this. Just one moment. Let me just see. Mhm. So, like this work here now, we made use of what we call bio-inspired algorithms, right? So this just the name, yeah, genetic algorithm optimization. So what this actually does, I did forget the name. That's why I'm just going this route. So what this actually does is that it will help to select the batch size, the training, everything. Maybe some other time or today, if I have time, I can show you guys the code. It does that for you. The only thing is that you must have to give it a vector of values, a range of maybe multiple values. It will automatically, based on your data context, it can now select the number of weights, the number of architectures, the optimization function that will be needed for it, and so on and so forth. So that is it. But for here, we're actually doing everything manually for the meantime, right? Well, like I said, this very first code here is actually doing within the outer layer is actually doing a kind of a kind of it's a way of randomizing the data, right? Are we there? So here now, that's what we call slicing in Python, right? You actually what this is just doing here is that I don't know, do we have knowledge about slicing in Python?
yes, sir.
Okay, no knowledge of slicing, right? So what this is doing that we are actually using this random permutation here, and this is just we are random. The random permutation is based on the length of our data set. Are we there? So like here, let me just show us because I want us to let it not be like a rocket science. That's why I'm just taking my time for this. Let me see. Okay, let's say if we go here, and then say uh have you seen even automatically the thing I just come up? So we want to know the length of this data set. That is, use this len function here. Mhm. Let's see. It seems I've not really implemented this code. That's what. Okay, I've not just implemented the code. So let me just do something here, and then here, and then here, and then here. Mm. So while this is going on, does any person have any other question? Have you seen the length is what? How many? 60,000. Have you seen it here? So that is what is really taking place here. That we actually, when it come here, right? We are just doing a kind of random permutation of 60,000, right? And then this now will now do the random permutation. What we'll now do is that if we go to the training sample, we now take values within these indices and then use it. Instead of taking this, we now extract a kind of extracting all the value from this based on the indices in these various samples. So that is just what is taking place here. The same thing repeats itself here. And what we are just doing that is that it will make our model to not to memorize or something like that's what we are trying to do the randomization process. So having done that, we then now start the main loop in here that comes in this second this in the inner loop here. So we are just still doing the slicing here, right? We are just taking S batch from a value of I because we've already defined our I, the range of our I within this very range. So we are now picking it here within this in value, and this is more or less what's it called again? A list. So within this range of values, we are not taking it. The same thing replicates itself to that of y. So having done that, we then now um, bring out the gradient steps that really helps us in the backward propagation process or the gradient this in computation. So having done that, we then now call this function here. So look at the function we have before now. This is the function here for reading in the input to the this into the layers. So this is where we are actually calling it here. So within this, we now because here from this function here, you find out that the input is x here. So that is what we actually will call it here forward and then pass our s batch as our input to it. So having done that, we then now do we even define our loss function? Okay, this is our loss function here. So we now compute the loss. So that is what the essence of this guy here. We are computing the loss and then assign it to this. So what this is doing here is this. For the loss, right? We are to talk about the y minus the y predicted value. So this is what we call the ground truth. And then this is just the predicted value. The logit is the predicted value, which is equal to our loss function, right? So having done that, we then now do this actually helps us in doing what we call back propagation process. So what really does the back propagation process is what we call the dot step dot gradient in TensorFlow. So that's just what does that. Now, having done that, we then now pass in our optimization process to the whole process, which is this. And then we'll now print out what is our epoch. So let's just run the code. And if any person has a question, you are free to ask. So I run this function here. No, first of all, just a sec. Okay, I run this guy here. Let me check Control Enter. Why is it not coming up? I'm looking for, okay. So we'll run this, and then we'll run the length, which still gives us this. And then this is just a number of our classes. This is just our network architecture. And then this is just our optimization process. Where to here our model. So here, this is what we call the S string. This is just one of the best methods or the latest methods of maybe reading something in the print. So what it does is that this very guy here, right, will now pick the value where it is and then place it here. And then we are dealing with 4 decimal places. So that is just what is happening here. So why we are just having this epoch is that we don't want to start from, Python start indexing from 0, but we are actually starting it with 1. So that's why we now send epoch plus 1. So that instead of having epoch 0, we have epoch 1, but that doesn't really mean much anyway. So why the code is running, do we have any question at this point in time, or are we still joking heavily? Okay. Any question?
Doc,
Mm-hmm.
you talked about you said that the main essence of all these things is for AI implementation.
Yeah.
Uh,
Yeah.
Actually, I want to understand, sir,
Mm-hmm.
because I know that AI is a vague subject,
Mm-hmm.
and I want to understand the particular section of AI that this
Okay.
TensorFlow Python is trying to address.
Yeah, you need it in as much as AI is very much concerned today, right?
Yes.
Either you use TensorFlow or PyTorch. You cannot do away with that. Either you use TensorFlow or PyTorch. Maybe for research, right? You see here that we have okay, Chikamsu.
Okay.
I'll answer your question later on, okay?
Yeah.
So
Okay, sir.
if you have a look here, find out that we have how many here. You see our last epoch. If that's what if we vary this in here now, or maybe say range of maybe 6, you find out that the thing will now just normal for loop that we know. It will now go down to this into 6. So having done the training, like in our own context, we have just training and testing. So we've actually trained our model. So we now proceed to do this in the testing, the evaluation process, so to say. So let this in finish running again, and then we'll run the evaluation. So what this is just actually doing is that for the logic test, right? We have to pass our this in, for the pass, we pass this in the training here, right? The S batch. For this, we have to pass our this in our since we are dealing with evaluation, we have to pass our S data set, which is the test data set. So having done that, we then now do the prediction. Prediction has to do with the logic, right? So we now have our logic test. I think we define it somewhere here, right? So having got that, we then now do our output. So we just want to output in integer of this 32. So that is just what we are just doing here. Now, and then for accuracy, you check the distance of accuracy has to do with the difference between that of prediction and then the ground truth. You can even check it online. Formula for accuracy, or even you can even ask it in ChatGPT, whichever one in machine learning, whichever one it just gives you, right? I've seen it now. Accuracy is equal to the number of prediction over the number of this in number of correct prediction. But I just want to check the mathematical notation of it. right? So that is the two positive plus two negative of the whole lot of this. So this is just what is just being built here anyway. So having done that, you then now print your output. So this accuracy before now is just in TensorFlow format, but for you to have it printed out, you just have to convert it to NumPy. So that is just, have you seen that this now just come to epoch 6? So having done that, you then now print your addition. Have you seen the accuracy is very small? Have you seen it now? Can we see the
Yes.
output? So you can vary this. Okay, let's just check something now. Let's make this into be the number of epochs. Let's say the training, because the training will now help to, let's make it 100 and see what will happen. These are some of the things that we need to vary anywhere. So let's just make it to be 100. It take a longer time. Yeah. So I think I will share this I'll share some books to you guys. And then this GitHub by this guy, by Franco's. GitHub by Franco's. Uh, okay. See this GitHub edition by this guy. That's the owner of the originator of Keras that using in TensorFlow now. So let me check deep learning with Python. So this is the book here. So let me check. We have okay. You see, I'll give you guys this book, and then you people will then now okay, this is the second edition of the book. So I'll give you guys the book. Maybe I'll pass it through Dr. Eziama so that you share to you people. But if you really want to go granular in the implementation process, you need to learn from his GitHub. Are we there? You need to go granular. This is the second edition, and then this is just the some of the implementation processes that he can actually learn. The good thing is that they're all in this in collab, so he can actually learn that. You see this one we've been implementing. Here it is here. So that's not a rocket science anywhere. So let's see what happens. Stop doing that, you for this boy. So the epoch will be up to 100. Let's see how it can affect the accuracy. So why I'm just showing this is that maybe you run your model and then it didn't get maybe the output to really appreciate. It can vary some parameters like maybe the number of epochs so that the training will be well trained. It can even change your maybe your optimizer either. It can change maybe to something like Adams or anything like that, or maybe I don't know. There's one they call flop, but check lots of this in of optimization functions that it can actually use. You can even check maybe the learning rate you're actually using, whether if it's really giving you the right this. So these are some variables you need to vary in the system anyway. So do you guys have any question? Any question?
Yes, sir.
Yeah,
Uh,
go ahead.
Please, sir, how many percent of our data set are we using for the training and the test?
Yeah, this is just from this standard, right? This is just a pre-built stuff, right? But I believe standard most of the times it can go 60, 20, 20, right? Some do go 60, 20, 20, or maybe 50, 25, 25. So that's just the standard. But this is just being taken care of by this, this is just a TensorFlow data set. This means data set is just, so the thing is just done and built. But
Okay.
maybe when we're dealing with a custom data set some of the time, if time permits, that's when we'll now see how, all those things are being, divided anyway. Yeah.
Okay.
Yeah.
Thank you, sir.
You're welcome. Any other question for people that will
Yeah, I
be
have a
going
question,
into
please.
yeah, go ahead.
Yeah, my question is when you have a data set
Mm-hmm.
X, Y, and Z axis,
Mm-hmm.
is it the same procedure you follow to get the result with a high accuracy?
Yeah, it's still the same thing. The only thing is that like this TensorFlow, let me just see here. This guy has actually done the heavy lifting for you because this has an inbuilt or TensorFlow data set, right? But then if you are actually dealing with custom data sets, see what you do. Like I said, everything you're just looking for is just it's online, right? Or even in all these large language models anyway. So let me lift my chat GPT, right? So maybe you can ask it the question, how okay, uh, how how do I split my custom data set and then separate the X being why we are having big S is just because it's a matrix and then a scalar and then S and Y, right? Or a vector, I mean to say, in maybe in machine learning. Oh, I say machine learning, but you'll understand. So, like, um, okay, have you can you see something here? Or is this so small? Hope you can see the screen, right? Can we see the screen?
Yes, yes.
Okay.
Yes,
So
yes.
for custom data set, you can make use of this trend test split by this guy by scikit-learn. But if you really want to go by, if you really want to add validation in it, you have to split twice. I'll show you guys. So let's assume that this is just your custom data set, right? And then how you go about that is that either you use slicing or you drop. Like here now, this is where we are actually dropping. So we are dropping this in the as is equal to 1, right? So you know, in Python, as is equal to 1, you're dealing with the features, the y as it. But if you say as is equal to 0, it then implies that you're dealing with the row. But in this case, we are dealing with this in the vertical axis. So that's why our axis is equal to what? 1. And then the label, he has actually figured maybe one of the features is being given the name label that when we need to drop. And then having dropped that, we now come over here and index it, right? So we are actually doing a kind of, we dropped it here and then we extract it from here using this indexing, or maybe, yeah, it's just an indexing. So we now extract it from the whole lot of this data set, right? And then having done that, we actually do the splitting, right? We now, because we've succeeded in getting our S and then Y, we now do our this in splitting, right? X trend, Y trend, this equal to you passing the value of your S, passing and then take the test size. The test size is about 20% here, right? And then random state. That is part of what we are actually doing here. That's what we are doing somewhere here. Let me see. Here. You see this permutation here we did, it's still the same thing here when you're using scikit-learn here. So that is what is taking place here, that you're giving around so that you have to shuffle your data set so that your model will not just do memorization. So somebody that asked question about this guy, what's it called? For this, the circuit LAN is just taking 80% for the training and then 20% for the distance testing. So I can further ask the question, can you add validation validation data set in the splitting? So see what will happen now. You're gonna do the thing twice, right? Let me see. Okay. Have you seen what is happening here? You get your S temp, right? I hope you guys are following what I'm doing, right? Are we following?
Yeah.
Okay. We assign our split in here as temporary. That's as temporary. That is for the training because we are getting this in the validation from the training set. S test, Y temporary, S Y test. So when we do this very first this in splitting, these are the values we get, right? So in the second splitting, for us to get our validation data set, we now say S train, Y val, did this in. So we now get our training and then testing from our destin from this our S and Y term. So you split twice for you to get that of your validation with this library or maybe module from a circuit LAN. Does that make
Why is
sense?
the test
Mm-hmm.
size increased to 25?
Sorry?
The test size there is now
Yeah, you
0.25.
can vary it. You can vary this. So it's not 0.25. It says 0.25 times 0.8, which is 0.2. Have you seen it? It just multiply the stuff. That's
Okay.
0.2. Yeah. So that is just what is just happening there. So it's giving you 60, 20, 20. This is just the standard. So it can just use the test size for this to 0.25. In the very first one, it can use 0.2. So which will now about than giving you 60 is to 20 is to 20. So that is just what is taking place there. So
How can we
mm,
increase the validation rate? Or this 20% looks small.
no, it's just the standard. It's a
Okay,
standard. Yeah,
standard.
that really makes sense that way. Yeah. So what you do, you don't just have to. What you do is that maybe if your model is not performing that well, you can increase the sample size, right? You can check the optimization function you are using. You can even check the activation function, whether if you are using like Relu is the best performing assist, and then Adam is, but I don't know whether that it will have Ara Adams and all that. But based on the context. In that case, the data set you are using. You can even change the number of layers, right? The number of neurons, the learning rate. So these are some things you just have to put into consideration. Does that make sense?
Yeah,
Yes.
yeah,
Okay. So
yes.
that is just the thing there. So I don't think we're gonna wait till this actually gives us um 100. But why I'm just doing that is that with only but training with 5 epochs, your model might not be well trained. It's not well exposed to the context or the data set. So in that case, you actually you can keep on increasing the stuff and then varying some other parameters in the system. So that is just how you can go about that anyway. So I think we're gonna stop by my 5 p.m. here. That's what time in Nigeria. I think that's 10 p.m. Nigerian time. So maybe some other
So
time
much.
I'll send you people maybe you have to, if you really want to do well in AI, mark this because this deep learning by this in the guy that the originator of Keras. So this is just Francois. He's a French guy. He's the originator of Keras, and this is just his book. I'll send you guys the book, and then so maybe when you read the book, you try practice because the lecture note is quite so comprehensive enough to maybe for someone that really want to have a start, in this. All these things we've been doing, these are all about it, So that will really teach you, like when you're taking batches. Like if you run this now, if you don't understand what this in batch makes, just copy it and paste it in ChatGPT and then say, give me a baby step, give me a baby step uh, explanation of this code and the annotations. So annotation involves if whether if it is slicing or anything at all. You finally give you a baby step explanation of it. So that's why I'm saying that things are way more easier for us this time around, that we don't need to bug ourselves. So see what it's just telling you here now, that now you must process this. Okay, let me say the baby step explanation of this. Have you seen that? What is training did this, right? It gives you the very first one. This is called slicing. This is what I mentioned much earlier. Turning this in. So when you put something like this, dot dot, it must give me all the images. But if you are saying dot dot, right, from this is starting from 1 to 8. It said that give me the first 1 to 8 images. Yeah, yeah. So like here now, like maybe from 1 to 128. Keep in mind that it starts with 0. So you're giving me the very first one. So but if you press something like this 128, it's telling you give me the last 128 values. But for here, if you put dot dot, you're selecting all the images or all the data sets. So this is just a simple knowledge about this in slicing in Python. So you can as well look into that, because that will actually help you in your data wrangling and every other thing. So that is it. So Dr. Joma, are you there? Hello, Doc, are
Yes,
you
I
there?
am.
Yeah,
I
please.
am. I am.
Were they able to fill out the form? Because we might have some new people that are not registered.
Yes, the host
Mhm.
and myself, we are
Mhm.
taking note. We've taken
Okay,
note of that, and we
okay,
would get back
okay.
to
Thank you
you.
very much. So, maybe next Sunday we are to look into PyTorch, because these are the two programming language that we can actually use in our core whatever thing we are doing. But for people that are actually doing research, maybe you want to do some publication or you're doing a PhD program or master's program, maybe in the next class, we don't need all this, going this granular, right? We don't need all this anywhere, unless, yeah, you just want to be a super good guy anywhere. So I will, I will just, you know, put us through on how we can actually develop a function and then import it in the architecture of the AI model. So in that case, it can easily infuse a kind of hybrid algorithm that can give you a novel output anywhere. So maybe having finished with the PyTorch, I'll put you guys through on how you can actually make your
Janet,
model.
aho.
You can make your models this in hybrid. So I think that ends for today's class anyway.
Thank you.
All right. Thank you
Yeah,
very much.
you're welcome.
Thank you.
Thank
I'm
you.
sorry I didn't even know I was
Thank
on
you.
unmuted.
Okay.
We've really spent some time,
Yeah.
about 2 hours,
Yeah.
on distinguished participants. Our host, the Rector of Federal Polytechnic Nekede, Dr. Mrs. Basilia Ibokwe. Our esteemed speaker, Dr. Elvin Ugonna. Ladies and gentlemen, it's been another highly insightful session on this journey of Webinar 3.0, part 1 of 3 so far. Mastering deep learning with Python. It's indeed deep learning. One skill, multiple domains. every day one new thing. And I cannot forget Dr. Elvin's comment. When we say, what is all this? Say, it is what it is. We can't wish it away. On behalf of the ICT Directorate and the Continuing Education Center, Federal Polytechnic Nekede, we sincerely appreciate everyone who has made out time to connect, to learn, and engage with us today. Yes, it sounded a bit advanced again, but I like the way Dr. Elvin was using some assistance, some of the AI assistance to mitigate. It was also like a double learning process. The coding, the Python coding, and then the usage of an aid to also assist us to speed up with the learning process. We want to say thank you, Dr. Elvin. Very big thank you for yet another practical delivery you have made again for us. Your expertise continues. It broadens out, and you're equipping us much for this fast evolving AI landscape. And to our visionary host, I greet her again. Dr. Basilia Ibukwe, thank you for your constant leadership and support and a constant approval to run this. And to all our participants, your passion for continuous learning is exactly what keeps this platform alive. Without you, we can't be this alive and relevant. We encourage you to keep practicing, keep applying, and keep growing. We will keep trying to bring up great and relevant, top-notch ideas and trainings to help ourselves. I learned a lot today, even though at the time I got lost. That's the truth. At the time I got lost. So we are all in this same ship. We're all in this same ship. So as always, we look forward to seeing you again next Sunday.
Okay.
By the special grace of God by 8 p.m. West African time for another enriching session like this. Thank you all. I don't know, while I'm looking at it, I wanted to see if there are questions on the chat section. Okay, they were all thanking, except I wouldn't know what Dr. Theodon Bata is saying. Let me read it out, Dr. Elvin. Memory limitations and software problems are some of the problems of not feeding all samples in a set. Okay, maybe a contribution.
Yeah.
It's not a question.
Yeah.
And somebody is asking for the material. We will get the material across.
Okay.
I really don't like to gather people on platforms because your data is sensitive. Unless I will have to open a Telegram where data can be hidden, phone numbers. I wouldn't want to have us. I know why, even when I'm sending emails, we blind copy because I do not play with people's data. Yeah, I don't do that. So, but I don't know, maybe we'll have to do this, sending these documents to you via email. The email we have collected through the Google form we shared, we kept sharing. So I think that is the means with which we, the team, would send those documents across as I receive them from Dr. Elvin. Opening WhatsApp groups because we have so many people from different schools around the nation and outside here. So if that is okay, I might go ahead and do that. But I also want to let us know that data these days and the policies behind data handling and management is becoming very sensitive, and a lot of people are using it to slam people to court and legal slamming. So I wouldn't want to do that if not authorized to do that. But I'll discuss with my co-convener of Continuous Education Center. We'll find a way to house us together at a platform whereby our personal IDs, like our phone numbers, will not be visible or emailed to the second person. So on this note, we always look forward to seeing you. We will do something about sharing these documents. And thank you all. Stay safe and have a beautiful week ahead. Thank you.
Yeah, thank you.
Thank
Thank
you.
everyone.
Thank you.
Yes, sir.
Thank you.
Thank you.
Yeah, thank you, Doc.
Sir, thank you for coming, everyone.
You're welcome, ma.
Yes.